Hello everyone, my name is Delaram and today I'm going to briefly explain our paper named No Query Left Behind Query Refinement via Back Translation. First of all the credits for the sketches on this slide goes to this Instagram page. So this may happen to you a lot. When you're searching for a query, you may not get the relevant documents that you're looking for. For example, here, the user is thinking about the fig fruit. She typed in the word figs, but she doesn't get the relevant documents. So she goes back and add the word tree at the end of the query. Now she gets more relevant documents. This is what is called query refinement, also known as reformulation and suggestion. Query refinement aims to transform the user's query into a refined version in order to get more relevant documents. Query refinement techniques can be categorized into two groups, global and local. Global techniques only use the original query to refine them, but the local ones also use the top K retrieved documents in order to extract the related terms and use them to maybe add them or use them to refine the original query. Most of the existing methods are trained on, especially the supervised methods are trained on search logs. Which they assume that the user's query is going to be gradually refined at the end of the search log. However, that's not always true, and topic drift may happen. So what is topic drift? Here's an example. A user is thinking about buying a new phone, so she typed in the query. Now she's looking for the brand's latest features, but suddenly maybe she saw an ad or she saw that the prices are too high, so she's changed her query and now she's thinking about fixing up her own phone, which is not related to the first query. That is what is called the topic drift. Other limitations to the existing work and methods are that they're computationally costly, it's hard to add new datasets, and due to users' privacy, there are not a lot of datasets that consist search logs. So here, the idea here is to generate the gold standard dataset, which consists with a pair of original query and the refined version, which supervised methods can be trained on them. We can use humans to generate those pairs, but it's time and resource intensive. It's hard to add new data sets, and their judgment may be biased. For example, here we got the word flies. One of them may be thinking about the insect, and the other one may be thinking about the fly. So we are going to automate this generation process. We're going to have a pipeline, which in this pipeline, we're going to apply multiple refiners. Then we're going to search and evaluate those results. And then we're going to aggregate the results together in order to create our data set with pairs of original and the refined version. As for the refiners, we propose using back translation as a refiner. Back translation is a simple idea which is going to translate the original query from its source language to the target language, then translating it back to the source language. What are the benefits of back translation? The first one, it can help by using another language, it can help to uncover those words that are common in the source language. Some words, due to background knowledge, may be latent in the original query. For example, here we got the word figs. After back translation, the word tree is going to come up, which is more related to the fig fruit. Next one is that it's going to help to add more related terms. For example, here we got the word, we got the query Italian Nobel Prize winners. After back translation, we're going to have Italian Nobel laureates. The word laureates is here is more related to winning a prize as opposed to other words such as champion or medalist. Next, we have Custer's last stand. After back translation, we're going to have Custer's last defense. The word defense here is more related to the word war and battle as opposed to other words such as upright body position or maybe a political stand. Here is our suggested flow, and we're going to explain it step by step. The first part is query refinement, which we're going to apply our back translation refiners, and we're going to calculate the semantic similarity. For back translation refiners, we suggest using Meta's translator named No Language Left Behind, or NLLB. We are using it because it's easy to use, it's open source, and it provides high quality translations for around 200 languages. And after that, to avoid semantic drift, we are calculating the semantic similarity between the original query and the back translated versions. And for that, we're using the declutter tool, which is using cosine similarity to calculate the score between those queries. Here is an example of that. The user is thinking about the fig fruit, so she typed in it. Figs has two different meanings. One of them is the fig fruit, and the other one is the name of the company which sells scrubs. So after back translation, we're going to calculate the semantic similarity to avoid topic drift and making sure that it's describing the fig fruit. Next part are search and evaluate. For each query, we're going to, using sparse retrievers, we're going to retrieve a list of relevant documents. Those documents are going to be evaluated with 3 different metrics, and a score is going to be assigned to each query. And in the last part, we're going to generate our gold standard dataset. Here, we're going to compare the score of the back translated version with the original one. If the scores are higher, we're going to choose that back translated query as the refined version, and we're going to pair them up and create the dataset. For this experiment, we are using 5 different datasets in different domains, from Wikipedia articles to news articles, non-factual questions, and queries from web pages. And we are using 10 different languages from 7 different language families. A language family is a set of languages that share the cultural roots and exhibit similarity in their grammar and vocabulary. And to compare the quality of translation, we are using the Bing translator, which comparing to NLLB, it's closed source. However, it is still providing high quality translations for around 128 languages. And to see the efficacy of our gold standard dataset, we are using T5 as a large language model to be trained on our datasets. So let's go through the research questions together. The first one, we're going to compare the performance of back translation to other unsupervised methods. Here, we can see that back translation generally outperform the other unsupervised methods. And tag me from global method, relevance feedback from the local method are the runners-up. And back translation, on average, can improve the results from 17 to 48%. Now we want to see the efficacy of language back translation across different language families and domains. Here, the bold numbers and the underlined numbers in a row show the highest and the second highest numbers in that row. By comparing the columns and the languages together, with each other, we can see that all the languages can generate a refined version. However, some of them has the best performance. For example, Chinese, Russian, French has the best performance among all languages, and the poorest performance belongs to Tamil and Arabic. It's worth mentioning that Chinese is from a different language family than English. So we can understand that it can help to reveal those latent aspects due to being uncommon in the source language. And also, using languages from the same language family is going to be effective too. For example, Russian and French are from the same language family than English. These languages can help to capture the semantic of the original query better. And in the different domains, the performance of the back translation in different domains depends on 2 metrics. One is the length of the query, and the other one is the variety of the topics in that query set. Here we are going to compare the length of the original query with the back translated versions. In those the query sets that already consist of short queries, back translation is going to add more terms to it to make it more specific. But on the other hand, in other data sets such as Antic, which already consists of long questions, by removing some uninformative terms, it's going to refine the queries. Here now we're going to see how our gold standard data sets are effective for supervised methods. Here T5 is, we have two different versions of T5. One of them is without fine-tuning, the other two are fine-tuned on our dataset. One is fine-tuned on our dataset with back translated queries, and the other one trained on our gold standard dataset without back translated queries. As we assumed, the ones that is trained on back translated versions outperform the others, and the poorest performance belong to the T5 without fine-tuning. And here we are going to compare the quality of translation between different translators. Here we can see that even by changing the translator, it still can help to refine some queries. However, if the quality of the translator is high, more refined versions is going to be generated. We have open sourced our pipeline. You can access it through our GitHub. And thank you everybody for your time.